Hi everyone, this is the AI Travel Companion Group, and today we are presenting a demo project for DSCI560 Lab6. And our project focuses on the oil well data wrangling, which involves the text extraction, web scraping, data processing, and visualization from scanned PDFs. And in this part, I will explain how we extract the data from PDFs and store it in a database. So let's look at the script first. In this PDF extraction.py files, it extracts structured data from well report PDFs and outputs two CSV files. One is the well header, and the other one is well stimulation. And it first reads each PDFs using the text extraction, and then it applies some regular expressions like this to capture the key metadata such as the operator, the API, the coordinates, and so on and so forth. And the results are clean and normalized and then written to CSV files. And the second script is the PDF to a db.py file. It imports the processed data from two CSVs into MySQL database. And we defined two tables here. One is well header, and another one is the well stimulation. And then we observed the data into these two tables. So now let's have a look at the tables. As we can see, we first defined a database here named oil well PDF extraction, and then we insert two tables. So the first table is the well header, which includes fields like PDF name, operator, well name, API, country, state, latitude, longitude, and so on and so forth. And the second table is the well stimulation, which also involves a lot of fields. For example, the PDF name, the date, the formation, the acid percent, LBS, top foot, bottom foot, volume, and so on and so forth. And next, my teammates will present the visualization and web scraping.
So I'm going to introduce the web scraping part of our project. This script scripted additional information of each well based on well names and API extracted from PDF, and create a new table in the database that contains information of a well from PDF and the website. This scripter uses the Playwright automation library to simulate a real browser, and each well is processed in an isolated Playwright browser instance to ensure stability and avoid interference between runs. The browser is launched in Herdis mode for efficiency, and it allows the script to interact with web page just like a human user. Firstly, we load the table from MySQL database that contains well information extracted from PDF and store it as a pandas data frame. Then we create a list that contains a well name and API based on this table. Now we are ready to extract well information of well status, well type, closest city, oil bridge, and the gas bridge from the well database website, and store the extracted information into another pandas data frame. If the field value is not exist on the website, we will use NA to represent the missing values. We first create a dictionary that stores the initial values. Then we create functions to extract field values in the table on the website, and the functions to extract numerical values of barrels of oil and gas produced separately. You use XPath and CSS selectors to do it. Now, we have an execution function cycle above extraction functions and collect all required field values from the website. After creating extraction functions, we are going to create a web connection function. For each well, this function constructs a search URL with query parameters of well name and the API using the URL encode function. Here, it then visits this URL directly to reach the search result pages. It will try multiple CSS selectors to quickly locate and click the correct search results. If no match is found within the timeout, it returns placeholder values. Okay, now this function organizes and call above functions to execute, launch the browser, navigate through search URL, extract required fields, and return additional containing field values. Finally, we iterate through the data frame for each pair of well name and API and repeat the above process. Here is the final table that contains well information extracted from the website. We can see that it creates a column for each field values. Now we are going to connect to the database and store the table into it. Finally, we join this table with the table contains information from PDF and store it as a new table. Here is the final well information table in our database. Thank you. This is all part of our web scraping in our project. Thank you for listening.
Alright, so this part of the video goes over the web app that we implemented for Lab6 for the oil wells of DSCI560. So this is the web app. This is just a simple landing page that just has a button that directs you to the map with the oil wells. So if we click on it, it takes us to the map. And as we can see, if we zoom out here a little bit, this is all in the North Dakota area. So all the wells that we extracted are around that area. And then each well in the map, if you click on it, it shows a pop-up with some of the additional fields that we extracted from the PDFs and from the wells website that we did after the PDF extraction. So we can see a ton of fields that we extracted, and then we're showing here as part of the pop-up. The pop-up is shown in two different columns, so data at the well level and then data at the stimulation level, and each well has its own corresponding data, obviously. If we zoom in, we can see there's a ton of different wells here, but yeah, each well has its corresponding data. And onto the code a little bit. So we did this using Flask for the backend. So our backend is using Flask as the backend framework. Then we're using Whiskey just as the application server. And then as the lab specified, we're also using Apache. So in this case, Apache is our web server, which is functioning as a reverse proxy essentially to our Flask backend. So we have Apache, then Whiskey, and then Flask. These are just the endpoints that we have. And then we have two HTML files. One is the landing page that I showed, and then this one is this is the landing page, and the map HTML is the actual map with the wells shown on it. And then yeah, that's pretty much it. The README has a sample template for the Apache configuration that we did. The file itself for the configuration isn't part of the repo, since that's like environment specific, so that's not actually part of the build for the repo, but this is pretty much the template that we use. We just plugged in our specific path to the project, but yeah, that's it. Thank you.